Late September 2025. Defense Secretary Pete Hegseth sends an order through secure channels. Hundreds of America's top military leaders, generals, admirals, and commanders, are to gather at a Marine Corps base in Virginia. The message is brief, marked Priority 1. No agenda, no explanation, no leaks. When word reached a retired general who'd spent decades inside the Pentagon's most secretive meetings, his reaction was simple. "I've never seen anything like this before. It just seems bizarre and dangerous." The general's statement triggered speculation everywhere. What kind of situation could summon that many high-ranking officers without warning? Some assumed a geopolitical crisis. Others whispered about something coming from beyond Earth itself. At that exact time, observatories across the globe had locked their telescopes onto a single object, a massive, fast-moving body entering our solar system from interstellar space. Misname? 3I Atlas. By the end of this video, you'll understand why this small detail changes everything. Shimmer from the start. 3I Atlas is only the third confirmed interstellar visitor ever recorded. The first was 1I Oumuamua in 2017. The second was 2I Borisov in 2019. But unlike those, Atlas behaved as if it didn't belong to the same family. It moved with purpose, following a path that cut close to the orbital lanes of Mars, Venus, and Jupiter. Its chemistry defied explanation. Telescopes detected massive outgassing, streams of carbon dioxide jetting from the surface at roughly 150 kilograms per second. Yet the object barely drifted off its gravitational trajectory. Crimson that single contradiction, enormous thrust but no deviation, is what drew attention far beyond the scientific community. The math didn't lie. To resist that much outgassing without altering course, the object had to be incredibly dense, at least 33 billion tons by some estimates. That makes it 3 to 5 orders of magnitude heavier than any interstellar object ever observed. Stiffness were cautious but uneasy. Military analysts were curious but alert, because when something that massive and unpredictable enters the neighborhood, everyone pays attention. The briefing nobody expected. Inside the Virginia base, the air was thick with speculation. Generals accustomed to battlefield reports now faced presentations filled with telescope imagery, heat maps, and orbital simulations. Generals' charts showed a glowing nucleus surrounded by an expanding cloud of gas, a coma stretching millions of kilometers wide. The presenters weren't intelligence officers. They were astrophysicists and defense analysts from the Space Force's Space Domain Awareness Division. Their message was clear. This was not a standard comet. Thermal scans showed intense heat signatures forming in fixed spots, regions that stayed hot even as the object rotated. Radar pings from the Deep Space Network showed reflective returns sharper than expected for ice, but not quite metallic. Infrared satellites that normally track missile launches had recorded unusual plumes hundreds of millions of miles away. And all of this data pointed to one unsettling truth. The object wasn't behaving according to nature's playbook, the science that broke patterns. Comets are simple, in theory. As they approach the sun, frozen gases heat up, sublimate, and burst from vents, pushing them slightly off their gravitational course. The effect is measurable and predictable. 3I Atlas was venting so much material that its course should have changed dramatically, and it didn't. Crimson dollar carbon dioxide jets that should have acted like small rocket thrusters barely nudged it. The only logical explanation was extraordinary mass. If those calculations were right, this wasn't a fragile ice ball. It was a fortress of rock, ice, and unknown materials. And yet its visible brightness suggested something else. A small nucleus hidden inside a massive, glowing halo. Two models emerged. Either it was a colossal body that shrugged off the sun's energy, or it was deceptively small, using dust and gas to appear enormous. Both models fit the math. Both were natural, but neither felt satisfying. Eyes across the planet. Telescopes on every continent pivoted toward it. NASA's Hubble and the James Webb Space Telescope joined the chase, analysing chemical signatures. The European Space Agency's ExoMars orbiter and Japan's JAXA satellites coordinated from different vantage points. For a brief moment, every major space agency on Earth was watching the same dot of light. Tightening their data painted a picture that only grew stranger. Atlas's composition was dominated by carbon dioxide, roughly 8 times more than water vapor. No comet in our records had ever shown that ratio. In simple terms, it was leaking the wrong kind of ice. Then came the thermal readings, pockets of heat that didn't match solar exposure. Normally, comets warm unevenly as sunlight hits one side, but Atlas glowed in fixed spots, as if something inside was generating heat on its own. The anomaly was now undeniable. The question was, how deep did it go? Military involvement. When the Space Domain Awareness Office began flagging the object for continued tracking, Space Command joined in. Not because anyone believed it was alien, but because it was unknown. And unknowns in space are treated like potential risks until proven otherwise. The military's radar systems, designed to monitor orbital debris, could also scan deep space objects. Their signals returned inconsistent textures, sharper than ice, rougher than metal. Analysts couldn't classify it cleanly. AI-assisted systems like Project Maven began comparing 3I Atlas's behavior with every known celestial pattern in decades of data. Nothing matched. Brightness fluctuations came in near regular intervals, but not quite periodic enough to suggest artificial control. Still, the borderline precision made some analysts uncomfortable. In the Pentagon, comfort is not part of the calculus. Risk is. And risk is measured in consequences, not probabilities. Risk math and the watch list. When a new object enters our system, it's categorized according to threat potential. Not because anyone expects danger, but because policy demands it. The checklist is straightforward. Timestamp. Does it move in controlled patterns? Does it emit any signals? Does its composition match known materials? Could fragmentation create hazards? Each question reduces uncertainty, but none eliminate it completely. 3I/Atlas ticked the unusual box in nearly every category. It was stable when it shouldn't have been. It was bright when it shouldn't have been. Crimson, it emitted heat in ways no simple comet should. That placed it on the watch list, monitored not just by astronomers but also by military space analysts, NORAD observers, and intelligence liaisons who normally deal with satellites, not comets. Patterns analysts. Fear. Space analysts look for one thing above all: patterns. Nature is messy, chaotic, uneven, random. Artificial systems are not. They repeat. If a brightness spike occurs every exact number of seconds, it means something is spinning with mechanical precision. If heat remains concentrated in one location regardless of orientation, it implies an internal energy source. If trajectory shifts contradict expected outgassing thrust, it suggests controlled motion. None of these have been proven in 3I/Atlas, yet none have been fully ruled out. And that is why the retired general's voice carried so much weight when he said, "I've never seen anything like this." He wasn't implying aliens, he was stating a fact. The data didn't fit any known pattern. The intelligence loop. Passionately behind the scenes, communication lines lit up between NASA, the Space Force, the Department of Defense, and civilian observatories. This wasn't the first time such coordination happened, but it was the first time it happened at this scale. Information flowed through encrypted networks designed for rapid threat assessment. Infrared satellites logged every thermal flare. Contentious space radar attempted to map the nucleus shape. Optical telescopes on Earth provided precise position updates. Every system told a slightly different story, but the big picture remained the same. 3I/Atlas was an outlier, melting so signs of artificial radio emissions were detected. No unnatural course corrections occurred. But the chemistry, the mass, and the stability still defied expectations. The turning point. By early October, as the object made its closest approach to Mars, data flooded in from orbiters around the red planet. From that vantage point, Mars Reconnaissance Orbiter captured unprecedented images. The object's coma shimmered with a greenish hue, likely due to carbon-based molecules fluorescing in sunlight. Symmetry, yet even then, its motion remained eerily consistent. No fragmentation, no tumbling. Just steady flight through gravitational lanes as if plotted on a course. At NASA's Jet Propulsion Laboratory, some scientists joked nervously, "If this thing had a flight plan, it's right on schedule." But behind closed doors, others weren't laughing. Because the more predictable its path became, the more unnatural it seemed. The public silence. Firefox official statements were minimal. Remarkably stable interstellar comet exhibiting unique chemistry. Shameful of Defense declined to comment on operational briefings. Misguided outlets speculated endlessly, filling the silence with theories that ranged from plausible to absurd. But those who attended the Virginia briefing described something simple yet chilling. Not fear, but discipline. Tightening, the message, they said, was to stay calm, collect data, and let evidence dictate response. Crimson happened. It wasn't panic. It was preparation. And in the months since, the world has watched 3I Atlas continue its silent journey through the inner solar system. Unbothered by the attention, unmoved by the sun's fury, and perhaps, just perhaps, carrying secrets we're not yet ready to understand. When the initial chaos settled, the scientists turned back to the data. Every reading had to be verified independently. The first priority was thermal behavior, the heat signature that tells whether a comet is behaving normally. Under sunlight, natural ice bodies warm up unevenly. Their surfaces crack, gases vent randomly, and heat disperses in unpredictable patches. That's what telescopes should have seen. But with 3I Atlas, the pattern was oddly structured. Certain hotspots stayed fixed even as the object rotated. That consistency broke the rulebook. Turbulence came trajectory sanity checks. Every comet drifts slightly because of its own jets of gas. The sun heats one side, gas escapes, and the object veers ever so gently off course. 3I Atlas didn't. Despite massive outgassing, it held its line with machine-like precision. Light curve analysis, the study of brightness variation, revealed another anomaly. Natural objects flicker chaotically because of their uneven shape. This one flickered in near-regular intervals, not perfectly periodic, but enough to make analysts pause. They weren't saying it was artificial, they were saying it was odd. The instruments watching it, unprotected. And the world, specialized systems joined the watch. Deep space radar arrays like Goldstone bounced signals off the object. The returning echoes told scientists about the surface, roughness, density, reflectivity. Ice should scatter radar in soft echoes. Rock produces sharp, grainy reflections. Metal returns clean, mirrored signals. The radar readings didn't fit neatly into any one category. They weren't metallic, but they weren't pure ice either. Something in between, compact, dense, strange. Smith-based infrared system, a satellite network designed to spot missile launchers, picked up the thermal activity too. Those satellites are sensitive enough to detect brief heat flashes hundreds of millions of miles away, and they recorded a consistent emission pattern from the comet's coma. This data wasn't high resolution, but it confirmed one thing: 3I Atlas wasn't quiet. It was alive with chemical and thermal activity. The results went up the chain of command, triggering an alert level known internally as Anomaly Review. That status doesn't mean danger. It means don't look away. The data that shocked the room. According to multiple internal sources, the key number presented during the September briefing was this: 150 kilograms of carbon dioxide vented per second, moving at over 400 meters per second. That kind of force should have visibly shifted the comet's trajectory by measurable degrees every day. But tracking data from 227 observatories showed drift below 15 meters per day squared. Physics demanded an explanation. Either it was the heaviest interstellar object ever recorded, or its outgassing was somehow compensated. Neither made sense. To illustrate the paradox, one scientist compared it to fog lights on a small car. It looks enormous, but it might be smaller than it seems. The light fools us. Still, every scenario came with a catch. If it was small, its brightness shouldn't be so high. If it was big, its stability shouldn't be so perfect. Bannon could military call wasn't about panic, it was about preparation. When numbers don't add up, protocols demand readiness. The framework for the unknown. Impartial. In that classified environment, the discussion turned procedural. How do you classify something that doesn't break the rules but bends them in half? Space Force analysts used a tiered system of review. When a new object crosses into detection range, it's catalogued under Space Domain Awareness. Reminds behavior deviates from models, it moves into enhanced tracking. If the deviations persist, it enters structured analysis. That's where 3I Atlas stayed for months. Each stage adds new eyes, new data streams, and new agencies. Missions NASA handles the science. TEMING, the Planetary Defense Coordination Office, runs orbital risk models. SETI monitors for artificial signals. Demolished branches keep watch, defense branches keep watch on sensor anomalies. This web of institutions has existed for decades, built for exactly this: the moment when a celestial visitor doesn't fit the mold. What would prove it's not natural? Shimmer. There are certain signs that would flip the status instantly. If 3I Atlas produced a narrowband radio signal that followed it across space, that would be undeniable. Natural signals scatter across wide frequencies. Artificial ones stay locked. Bombings if its light flickered in a perfectly repeating pattern, that too would raise flags. Nature doesn't operate on precision timing over long observation periods. If radar reflections showed geometric shapes or flat surfaces repeating symmetrically, it would imply structure, not chaos. Tangled and the ultimate test: motion. If its trajectory ever shifted in a way inconsistent with solar forces or venting jets, a sudden, deliberate curve, that would be the game changer. So far, none of those boxes have been checked. But the fact that they're watching for them tells you how seriously they're taking it. A lesson in controlled curiosity. One of the most quoted lines from the debrief came from a scientist who simply said, "Curiosity is not fear. It's preparation." That summed up the entire operation. Every spacefaring nation is learning how to separate wonder from panic, how to study anomalies without succumbing to speculation. For decades, humanity's understanding of the cosmos has been limited by distance and perspective. Now, with interstellar visitors flying straight through our system, we have data from the beyond. Material not born from our sun, carrying the chemistry of other worlds. That's why 3I Atlas matters. It's not just another rock in space. It's a messenger from somewhere else, older than Earth itself. The bigger picture. Astronomers traced its path backward and found it likely came from the direction of the Sagittarius region, near the galactic core. That's an ancient part of the Milky Way, populated by old stars and low metallicity systems, remnants from a different era of the galaxy's formation. If 3I Atlas truly originated there, it could be 7 to 14 billion years old. Older than the solar system itself. That means the material inside it predates everything we know. It's a time capsule from the dawn of creation. Understanding it isn't just about solving a mystery. It's about learning where we came from. Of watching the skies. With the Vera Rubin Observatory coming online, detection rates for interstellar objects are expected to skyrocket. Crimson, during its first test runs alone, Rubin found more than 2,000 new asteroids in just 10 hours of scanning. That same system will identify dozens of interstellar bodies every year once it's fully operational. What was once rare will soon be routine. And that's the lesson behind 3I Atlas. Not to jump to conclusions, but to build a framework for when the next one comes. NASA, ESA, and other agencies are already drafting mission concepts for rapid intercept probes. Small, fast spacecraft that can be launched within months to meet a passing object head-on. These missions would carry cameras, spectrometers, and radar instruments. Not weapons, not transmitters. Observation only. Their purpose? To see up close what telescopes can't from millions of kilometers away. The idea isn't science fiction. The technology already exists. It's simply waiting for the right target. The role of SETI and protocols. If 3I Atlas or any future visitor ever emitted an unmistakably artificial signal, an established protocol would take over. SETI's post-detection framework, developed decades ago, dictates the sequence. Verify independently. Rule out terrestrial interference. Cross-confirm with multiple observatories. Sentence notify international agencies. No single nation decides what happens next. The process moves through the United Nations and global scientific councils. The goal is simple: transparency without hysteria. Until that threshold is crossed, scientists remain observers, not alarmists. Murky from the briefing room, Mitters. Inside that September meeting, one general reportedly leaned back after hearing hours of technical data and said quietly, "So the universe just threw us a curveball." Refreshed. And that's exactly what it was. A curveball from interstellar space. No one claimed it was a threat. No one suggested an invasion. They simply admitted that for the first time in a long time, something had entered our region that didn't play by the normal rules. That acknowledgement alone was historic. A retired general later described it best. It wasn't fear that filled the room. It was the realization that we're still students in this universe. And the lesson plan just changed. Simmons, the lessons learned. 3I Atlas forced scientists and strategists alike to rethink how they classify anomalies. It exposed the need for faster response networks, clearer communication, and tighter coordination between science and defense. It showed that awe and readiness can coexist. Every new reading, every radar echo, every pixel of data brings humanity one step closer to understanding not just what's out there, but how we respond to it. For now, Atlas remains on course, gliding silently through the inner solar system, reflecting the light of our sun as it prepares to leave for the stars again. No confirmed signals, no course changes, just the steady whisper of cosmic chemistry trailing behind it, the echo of a traveler from another world. If you found this story fascinating, subscribe for more updates as new data on Atlas arrives. Like this video so it reaches more curious minds. And remember, the most powerful thing we can do in the face of mystery is to look up and keep looking.